In this video, I'm going over the color sensor and how to use the color sensor with the Hovercraft. All you have to do to get the color sensor on here is you have to solder it to, or have me solder it to right here. So there's a little color sensor in there. It's hard to see it. The color sensor is on the surface of the bottom. You definitely, if you're using the color sensor, don't want to have it, you don't want to have it on a board that doesn't have a ring around it, because if it is, it's going to scrape and it's going to destroy the color sensor basically immediately. So the issue with the color sensor is these color sensors, they detect the intensity of red, green, and blue light. And to work properly, if they're perfectly calibrated, to work properly, they basically rely on the light source being a perfect balance of red, green, and blue. But to get a light source that's like that, it's very expensive. We have these LEDs down here. There's 3 LEDs that shine downward, so they shine down through holes from the top of the circuit board. And the reason we have the LEDs shine from the top of the circuit board is because you don't want, when you're doing color detection, you don't want the light directly hitting the color sensor. Otherwise, the color sensor is just going to get washed out by the white light. To avoid that, basically, we have the LED shining from the top, so the circuit board itself kind of blocks the light that shines from the side. So the light that hits the color sensor is the light that shines through, reflects off the surface, and comes back. And it's not perfect. There's a little bit that leaks through. One thing I found is the default of these lights are very bright. So these lights are very bright, and so to prevent it from being totally saturated, I had to go into the driver file that I had, and in the driver file, so I've got it open here. You can't edit it from Arduino, but you can open it and look at it, so I'll show you. So I think it was right here was what I had to change. So I had to change this from integrating at 160 milliseconds to, I believe, integrating at 40 milliseconds or something like that. Let me see if there's... Yeah, so I had to set it to, I think 80 milliseconds is what I needed to make it work. So you can change it in the driver, or there's a way you can change it in your actual main code for your program. If I did that somewhere, did I do it here or? Yeah, maybe I didn't do that here. But basically, you're gonna have to, probably if your lights are too bright and your signals are just all really high, you're gonna have to change these values here. So basically it's integrating the light that hits it over 160 milliseconds, or it's integrating over 80 milliseconds or 160 or whatever. So you can change that line in the code, and we'll see what happens when I compile it now. And if it's saturated, I'll show you what saturation looks like. So what I'm doing is, the first thing I'm doing is just inserting in the startup of my code a little bit of code here that just reads the red. I have 3 variables, red, green, and blue, and they are, in this case, they're defined up, I don't know where they are. Did I have them? Oh, this is weird. My code is strange. I used to have it. Maybe I modified it, but... Oh, here we go. It's right down here. UN 16T red, green, blue. I have this while loop just for testing right now. I just go through a while loop and I just write all of these things just indefinitely. So I basically just continually loop through, read the red, read the green, read the blue, and then I print those values. And we're going to look at what those values are on the screen here in a sec. So doing this code, let's see what it does. I think this one's going to saturate. Now in this case, because we're reading values off the serial, we want to make sure that we have it set to be USB CDC on boot enabled, and we're going to keep the wire plugged in while we're doing this. We can see it. Blue was not declared in this scope. Yeah, where was that then? Oh, yeah. Oops, I think when I showed the ints, it was the wrong one. So let's go back to here. Maybe I accidentally deleted it. Now here's the thing, as this is compiling, when we do the color sensor calibration, we want to do it with the air on. We want to have this thing be floating, and that's a little tough with the cable connected to it. You got to kind of hold it. Oops, we got a problem here. Oh, you know what? I have Cura open. Okay. Cura likes to grab if it sees an open USB to serial, it thinks it might be something like a printer that it's trying to connect to, so it grabs it and it messes with your stuff. There's a few programs that do that. But the reason we want to have it floating is because when the hovercraft is floating, it's actually further away from the surface. So it's going to get a slightly darker, it's going to get a little less light being a little further away. It's going to be a little lower value while floating than it is while it's like right up near the surface. So when we do the calibration, it works best if we calibrate it with everything floating. So we're going to restart this, and we are going to go Tools, Serial Monitor. So you see, this is reading these values. They're not quite saturated. Yeah, I guess we can keep it at that. That's okay. But let's turn it on and see what happens. Loop it on. We're doing it on white paper for a little bit, and then we're going to do it on black paper. I'm going to stop it. I'm going to pause this display. Okay, so we're going to go back through and look at the colors here. So while we were on white paper, we had our values right here. While we were on black paper, we had the values right here. So we want to go through and look sort of what was the intensity of the color on the white paper, which is going to be basically the brightest color we can see, and then what's the intensity of the color on the black paper, which is pretty much the darkest we can see. So on we had a couple weird random values here, but it looks like for the red we got about 13,800. So what I'm going to do is I'm going to save my highest value. So my max red is 13,800. We're going to keep it about there. My max green is going to be, looks like maybe 16.5 or something like that. 16.5 is about the highest I see. Let's go 13.9 here. And then this will be about 16,500 or so. And then the highest blue that we see, other than this one random one that was popped up here, it looks like 16, let's go 16.2 or let's say 16.2. Okay, so that was, we got our max values for on white paper, and you can see they're not totally balanced. The red is a little bit dimmer. That could be because the paper we're using. That could also be, it's probably more likely just the lights. So the lights probably lack a little bit of red in the balance of red, green, and blue. Now let's look at on black paper here. When we were on black paper, we had, this is going to be our minimum value. Our minimum value is something like maybe 11, let's go 1180 or so. Min red is about 1180. Min green is going to be about 15.5 maybe. And then min blue is going to be 1270 or so. Okay. So by putting the hovercraft, having it hover and putting it over white paper, we get our maximum values, and over black paper, we get our minimum values. And the reason over black paper we're still seeing a signal is both because the black's not a perfect black. It's not like a Vanta black or one of those crazy things that absorbs 100% of light. And also because we do get a little bit of stray light that scatters off the surface of the board sideways. But knowing the maximum and minimum values we get on white and black paper is going to allow us to do a calibration for color. So let's say we're over a color. If we were over an actual red, if we were over a patch that was the color red, we'd probably see a red value that was like here. But if it was a pure red, the other colors would probably be somewhere down closer to here. And so to determine the real magnitude of red, green, and blue of the colors we're over, what we're going to do is we're going to, after we save our maximum and minimum values, we're going to basically say, okay, if we read a red, green, and blue, the real fraction of red, so the fraction of red between the dimmest red and the brightest red, or the basically no red and max red, is going to be the value that we saw for red minus the minimum it can possibly be. So if this value of red was at the minimum, this would produce a 0. And then we multiply that by 128, or, well, ignore this for a sec. We take the value we read, subtract the minimum it could possibly be, then we divide by the maximum minus the minimum. And this is going to give us a value between 0 and 1 that is either the minimum red we see, if it's a magnitude minimum, or the maximum red we expect to see if it's a value maximum. And we can do the same thing. I multiply it by 128 here just because I'm trying to drive the LEDs to the color that I see. So if the red value minus the minimum divided by the maximum minus the minimum gives me a value between 0 and 1 for that magnitude of red, if I multiply it by 255, it's going to drive the LED from 0 brightness to 100% brightness. In this case, I'm just multiplying it by, in this case, I'm just multiplying it by 128 because I just want to, I don't want to have these LEDs be super bright. I'm just going to go half brightness. We do the same thing for the green and the blue. So once we know the max value we expect to see and the min value, we can use a little equation to basically say, okay, the color that I'm actually sensing, what portion of it is red, green, and blue? And then in this case, we're going to write it to those LEDs. So the only thing we have to do now to make this work is we have to remove that code that we had in here that was doing the while one. So we got to remove all this code so that we can actually get out of there, and then we should, and then, ooh, I messed something up here. What did I mess up here? Okay. And then the rest of it should do what it's trying to do. So let's try this. Let's reset our board. And then upload this. And I'm first going to test this on the black and white paper, just kind of see how it looks. One issue we might have is it is possible if we go over a black that's blacker than we expect, we could get a negative value. And so I didn't really have code that handles it. I guess we could have done like the absolute value or done like a if our number was possibly negative, we just say, you know, if it's negative, make it 0, or we could do a max function where we do the max of that plus max of that times or max of the number and 0. And so if it's negative, it'll just give us a 0. I screwed something up. Let's screw it up here. Line 90, we have, oh yeah. Oops. Oh boy, I really goofed this up. Oh yeah, I commented out that. That's all, I guess that's all commented out. Let's see what happens. Okay. So now, let's put this back. So I put that back. I'm leaving the servo off. I'm not going to use the servo because I don't need it, but I am going to let it hover. So yeah, the lights go black when it's over the black now, and they go light, they go white when they're over the white. That worked pretty well. Now let's see what happens if we go over the piece of paper with a whole bunch of colors. So this is a little small scale. It's probably, we might be getting kind of multiple colors as it goes around, but let's see what happens here. So it's much more impressive. It's much more impressive on the screen. I mean, it's much more impressive when I look at it, but that looked pretty good. So it was changing colors fairly effectively based on the color that it was over. One thing also, if you want to make it more vivid, if you want to make the distinction between the colors more vivid, one thing you could do is you could square this value. So the value that, so instead of being times 128 here, you could take this value and do the square of it, which I think is, well, I guess to do the square of it, we could just do that, times that. and then times 128. So again, if this is between 0 and 1, when we square it, it's just going to kind of exaggerate that, right? If it was half, it's going to now be a quarter. If it was 1, it's still going to be 1. So if you notice the colors being a little bit too washed out, this is one technique that you can do. Okay. And let's see how that does. Maybe get a little more exaggerated color. Oh, you know what? I totally messed that up. Hold on now. I think this is going to end up being wrong. Yeah. I messed that up. Well, oops. That's my problem here. Let's try that. It expects 4 arguments to provide. Yeah, okay. Comma. Well, it probably means I have a parentheses issue here. Yeah, looks good. Looks good. Okay, now we should be good, finally. So that was nice, yeah. Squaring the number, and then multiplying it by 128 gives a much more distinct, less washed out. And the normal process of doing that is called gamma correction. It's not actually a square, but a gamma curve corrects light that is emitted from a source rather than like a pigmented light. But light that's emitted from a source quite often, your eyes, you want to provide a more exaggerated scale of the color because your eye is really sensitive to emitted light in the sense that you can see things in a dark room or out in bright sunlight in the middle of the day in Arizona because your eyes are able to adjust and you can see a wide range of magnitude of orders of magnitude of intensity of light. Gamma correction kind of helps make the distinction between those brightness levels a lot easier to see. We're not actually doing a gamma correction here. We're just squaring a value between 0 and 1, but it's kind of a similar behavior. So if you want the color sensor, let me know. I can solder it on your board and you can do fun stuff like this. It's kind of nifty to see that work. All right, thank you, everybody.